Welcome to another episode of Steele Creek Explorer. I'm your host, Jeremy Stout. And the weather today is not the greatest outside, but that's no reason why we can't have a natural history adventure anyway. We're going to go out into the park, take a short walk today, and bring a few items back, and we are going to explore the very, very small. All right, so let's learn a little bit about microscopes before we take our microscopic adventure. What's really amazing when you think about a lot of the sciences, they have a history that goes back, many hundreds or even thousands of years. If you think about our modern understanding of physics or astronomy or even chemistry to some extent, these are sciences that go back to some of the earliest thinkers. Thinkers like Aristotle and Democritus and Eratosthenes. These are all workers from before the time of Christ that were trying to answer these big scientific questions. But if you think about microbiology or micromineralogy or anything that involves looking at things that are very small, those are sciences that were completely out of the realm of human understanding until the invention and widespread use of the microscope. The microscope did more for biology, I would argue, than even the telescope did for astronomy, although they have a very similar history and both come from about the same time. Cells, the building blocks of all living things, were completely invisible to us until just the 1600s, which, as far as scientific thought goes, that wasn't all that long ago. And it wasn't until just yesterday, metaphorically, that in 1839, Schleiden and Schwann gave us the cell theory, which is that all living things are made up of cells, at least one cell big. So when it comes to microscopes, there are a few different varieties. We're not going to be using an electron microscope. That's something that we don't have. It actually doesn't use any eyepieces at all. What we're going to be using today are light microscopes. And as the name would suggest, these microscopes work through a fairly simplistic process of channeling light into a lens, and then there are some eyepieces from which the user views whatever the object is on the stage of the microscope. I'd like to go ahead and give a quick shout out and thank you to our Blue Stocking Club right here in Bristol. In addition to funding one of our major exhibits in the Nature Center, the upcoming geology exhibit, they also purchased these two microscopes for use in the classroom where we are today. So thanks very much to the Blue Stockings. Excited to put these to use today. So these microscopes might look similar at first. They are both light microscopes, but these microscopes do slightly different things. This is the one that you might be familiar with. It looks like a microscope. This is what we call a compound light microscope. This is a microscope that actually has multiple lenses that compound an image many times over. So you can view things at over 100 times magnification with this microscope. So for something that would be invisible to your eyes, this microscope would allow you to see those things like individual cells in a human or other living thing's body. It's a compound light microscope. Our other microscope that we're going to be using today, this is a little bit smaller, but it's the same principle. It's still got lenses. It still has light that comes from underneath. This is called a dissecting scope. And it's not used only for dissections, of course. You can use almost anything on this scope, but this is not for seeing something that would be invisible to you. This is a microscope that is really, really good at seeing things that are very small closer up. So if you wanted to get a look at Abraham Lincoln sitting inside the memorial on the back of a penny, which you can just barely see, you could put that penny underneath this microscope and get a pretty good look at him. In fact, maybe we'll do that later in the episode. Both of these microscopes are what we call binocular microscopes, which just means that they have an eyepiece for each of your eyes when you're looking through them. So without further ado, let's get out into the park. It's cold and a little precipitous outside, but we'll see if we can find a few things and try out our new microscopes. We're back in the classroom. We only went a few feet around the Nature Center, but we found some really interesting things that may be sort of mundane things until we look at them up close. Have found a piece of rock salt that's been laying out in the rain after snow that we had recently. Found a piece of living moss that we want to look at pretty quickly so we can get it back to where it came from. We don't want this stuff and anything living inside it to die. We also found a bird feather from a common species of Steele Creek Park. This is a feather from a Canada goose that I really want to see something close up on. We'll talk about in a moment. And we didn't even have to leave the building itself to find discoveries. Unfortunately, this little lady beetle right here was dead when I found it, but we found it in a windowsill. So we'll put it under the microscope and see what we can see. But first, let's go take a look at the first object on our microscopy checklist, the goose feather. All right, this is something I've always wanted to look at under a microscope, and I've not had too many opportunities. Many years ago, I learned that birds actually invented the zipper in their feathers. And this is something I've done as a demonstration in front of groups of children and adults my entire career. And I know what's supposed to be happening, but I've never actually seen it at the microscopic level. If you ever take a look at a bird feather, you notice to be so lightweight, they're fairly strong. If you start to pull the ends of the two pieces of the vein apart, that's the broad part of the feather, there's a little bit of flexibility, but if you pull too hard, oh no, we accidentally broke this feather in a couple of places. Bummer, what's the poor goose to do? Well, not to worry. I read about this in textbooks in an ornithology class. Birds actually have a microscopic zipper in their feathers. And so if you take this feather and you run it between your fingers a few, dozen times, then you're actually zipping the feather back up at the microscopic level. And if you give it a little tug again, looky there, you've repaired it, okay? So there are these microscopic structures on each little filament of the feather called barbules. And let's put them under the microscope and see if we can see them. All right, so before we see if we can find those actual microscopic barbules, I think we're going to find them. Just to show you the power, we're using that compound light microscope, which I said is good for seeing things that would otherwise be invisible to you. Just went ahead and put the feather underneath the microscope. And what you're seeing there are those individual filaments. These things are thinner than a human hair, or those big dark bands you see across the screen. And this is the lowest magnification setting on this compound microscope. So if we choose, we would be able to see individual cells from inside this feather. But now let's take it off and let's break that feather again. All right, so here's that broken edge of the goose feather. How cool is this? You can see those filaments, those barbules, and these sort of look like ratty edges. Looks very similar to if you were to look at Velcro underneath a microscope, or even a very similar interlocking structure as you would find on a zipper. So you can see how those would meet up with filaments on the other portion of the feather and just zip right up. You might say, Jeremy, wait a minute, how can the birds zip their feathers back up? They don't have fingers to do it like you do. Ah, that's true. But if you've ever noticed a bird sitting or standing and running its wings through its bill, over and over, they'll run their feathers through their beaks, and that's actually what they're doing. They're repairing damage and zipping these feathers back up. And so here you see the microscopic mechanism by which they do that. Too cool. All right, so now we've traded out our compound light microscope for our dissecting scope. Again, this is for seeing things that you can already see with the naked eye. Now you can see them much closer up. You can see detail that maybe you couldn't see before. And wow, does it not disappoint. This was our piece of rock salt that we found on the side of the road. And it's rained a little bit since the snow fell, and the salt has actually started to dissolve along its outer edge. And so here, under microscopy, you can actually see those zones of dissolution where rainwater just bouncing off this little cube of salt has actually started to pit and texture the side of the salt. It's also interesting how under this microscopy, the salt crystal actually looks opaque. It looks like it's dark in color. Whereas if you look at it in the hand, it appears clear. All right, we've switched out our rock salt. Now we're looking at the face of a lady beetle. How cool is this? Here you can see, remember, what we often call ladybugs, they're not actually bugs at all. They are insects, but bugs are a different group of insects altogether. Lady beetles are just that. They are beetles, and they have these hard outer wing covers. And on this particular dead specimen, if we can position it just right and change our focus, you might actually see, there it is, sticking out of the posterior is a little bit of the actual wing that the lady beetle would use to fly with. All right, let's take the lady beetle off, and let's take a look at this whole forest of a small piece of moss that we found beside the Nature Center. Looky here. We have got a small mite or some other arachnid that is actually crawling around in this moss. Probably doesn't like the light that I'm shining on it. Look, here are some structures of the moss itself. We might be able to change our light and our focus. Remember, even though this piece of moss that we found was only, it wasn't much bigger around than a quarter, remember, this is a whole world to tens of thousands or millions of microscopic creatures and single-celled organisms. We found that tiny little mite. There's something else I was sort of hoping we would find in here today, is a group of animals that occur worldwide, and they are very tiny. And they go by some really colorful names like moss piggies or water bears. They're actually their own phylum of animals called tardigrades. And they're really cute as tiny insect-like creatures can be. And one of their favorite habitats is moss. So while I'm not finding any in this sample, we do know they occur in Steele Creek Park, and pretty much every other habitat in the world that you look for them. So cool. Okay, just since we mentioned this at the beginning of the episode, I went and I found a penny that I had laying around. Many of you at home may not know this. We all know that Abe Lincoln is on the front of the penny, and that building on the back of at least the older pennies, the new pennies don't have that building. That's the Lincoln Memorial. And if you look very close, right in the middle of that Lincoln Memorial, you don't need a microscope to see it. With your bare eyes, you can look and see that there's a teeny tiny Abraham Lincoln statue that sits inside that memorial. So here we are, we've got the penny. You can see right there at the end of one and the beginning of cent. And let's go ahead and, oh, there's my finger, weird. Let's move that into the field of view. Oh, there's the base of the memorial. Up the stairs we go. And looky there. There sits Mr. Lincoln. Thanks for coming along with us today as we explored the very tiny world around us. Remember, whether you're looking at galaxies that are billions of light years away, or you're looking at those tiny little red mites that are living in the moss, whatever direction you choose to look, there is a universe in that direction. Infinity all around us, whether it's very large or very, very small. But do come out to Steele Creek Park and explore the tiny and gigantic world around you, because here's where you can be the explorer.